All right, let's dive right in. We're about to go on a seriously mind-bending journey, right to the edge of what we think we know about reality. See, the James Webb Space Telescope, it's been sending back some truly wild stuff, things that could basically force us to rewrite the textbooks on the universe. And today, we're going to unpack a brand new theory that tries to make sense of it all.
Okay, so let's just rip the Band-Aid off with a huge question. What if the Big Bang wasn't the beginning? What if our whole universe, everything you see, everything you know, what if it's just the latest chapter in a story that literally never started and will never end? I know, it's a crazy thought, right? But stick with me because that idea is central to the cosmic mysteries we're about to get into.
So, the first puzzle piece that tells us something is, it comes straight from the James Webb Telescope. It's peering back into the dawn of time and spotting galaxies that just shouldn't be there. They're way too big, way too bright, and honestly way too complicated for how young the universe was. It's like they grew up overnight, looking totally mature when they should have been cosmic babies. How on earth is that even possible?
Okay, and if you thought that was weird, the next piece of this puzzle is just as bizarre. In some spots out there, Webb is seeing gravity, but no stuff, no matter. There are these gravitational effects, this pulling, where there's nothing visible to cause it. It's like these invisible phantom fields of gravity are yanking things around from who knows where. And then there's the third thing, and this one is really eerie. Scientists have found this faint, rhythmic signal, almost like a cosmic heartbeat, just echoing through the universe from the dawn of time. And the weirdest part? It's not coming from any star or galaxy or anything we can point to. It seems to be baked into the very fabric of space-time. So, you see the problem, right? We've got three totally bizarre observations that our current understanding of the cosmos just can't handle. We need a new theory.
Okay, section 1. So how do we even begin to solve these puzzles? Well, a really bold new theory says we have to go back to basics and rethink the most fundamental force there is: gravity. What if gravity hasn't always played by the same set of rules?
So here's the core idea. Way back in the early universe, gravity was way, way stronger than it is today. Orders of magnitude stronger. This new theory introduces something called a Scalaron field. Think of it like a giant volume knob for gravity, for the entire universe. In the beginning, this Scalaron field had the dial cranked all the way up to 11, amplifying gravity's pull. And with gravity supercharged like that, boom, you could absolutely get those giant, mature galaxies forming at lightning speed. It solves puzzle number 1.
All right, section 2. And what's really fascinating is that this idea of changing gravity doesn't just solve the galaxy problem. It completely flips our origin story on its head. If gravity can change its own rules, then maybe, just maybe, the Big Bang wasn't a one-off explosion from nothing.
Yeah, instead of a singularity, that infinitely dense single point, this theory suggests something called a cosmic bounce. So picture this. There was another universe before ours. It was contracting, getting smaller and smaller, but right before it collapsed into nothing, it bounced. It rebounded, and that bounce became the massive expansion that we call our Big Bang. So our universe isn't the first one. It's just the latest beat in an endless cosmic rhythm of crunching and bouncing.
And here's the kicker, the really crucial part. This theory says those galaxies the Webb telescope is seeing, they're not brand new. They're relics. You can think of them as cosmic fossils that actually survived the bounce from the last universe. The reason they look so old and mature is because they are old and mature. They're carrying the memory of a cosmos that existed long before ours.
Okay, section 3. So that explains the ancient galaxies. But what about that other mystery, the phantom gravity? How does this new theory tackle those gravitational fields that seem to pop up out of nowhere?
All right, brace yourselves, because this is where the theory gets even more wild. The proposed explanation for this phantom gravity, it might not be in our universe at all. What if gravity is literally leaking, bleeding through from another reality that's existing right next to ours right now?
So remember that scalar 1 field, the one that acted like a volume knob for gravity? Well, this theory suggests it has a second job. It can act as a bridge, mediating interactions between parallel universes. And if that's true, it means those phantom gravitational fields that Webb is seeing, that could be the literal gravitational pull of stars and galaxies in another universe leaking across the dimensional barrier into ours.
And this also explains why the phantom gravity only shows up in specific spots. The theory predicts these things called supergravitons, which aren't really particles, but more like contact points, places where our universe gets incredibly close to a parallel one. These are the hotspots, the places where the veil between worlds is at its thinnest, allowing gravity to leak through most powerfully.
Okay, section 4. We've got the ancient galaxies and the phantom gravity covered. But what about that final puzzle piece, that weird cosmic heartbeat? If the gravity is coming from another universe, where is this rhythmic pulse coming from? Well, the theory says the answer isn't in another universe, but in the actual physical shape of our own.
The technical term for this is non-trivial topology, which is just a fancy way of saying the universe has a complex shape. So instead of imagining it as a huge, flat, infinite sheet, picture it being folded or curved back on itself, maybe like a donut or something way weirder. A shape where if you travel in a straight line for long enough, you could actually loop around and end up right back where you started. It would be like living inside a cosmic hall of mirrors.
Now, if the universe has a shape like that, it could cause light to literally bounce off the large-scale structure of space-time itself. That would create the cosmic echo we're detecting. And the heartbeat? Well, get this. The theory says that's the Scalaron field, our old friend, oscillating in perfect harmony in resonance with the overall shape of the cosmos. And just like that, the exact same field that explains the ancient galaxies and the phantom gravity also explains the cosmic heartbeat. It all connects.
So, section 5. I mean, what an incredible story, right? It's this beautiful, all-encompassing idea that connects ancient galaxies, phantom gravity, and a cosmic heartbeat into one single framework. But is it just a cool story, or is it actual science? You know, the difference is that a real scientific theory has to make specific, testable predictions. And the good news is, this one does.
So here are the smoking guns that scientists can actually hunt for. First, the theory says those phantom gravity fields should leave a very specific, unique fingerprint on the cosmic microwave background. That's the leftover light from the Big Bang. Second, if those old galaxies are really relics, they should have a kind of layered structure inside, like cosmic tree rings, revealing their formation in a past universe. And finally, that cosmic echo. It shouldn't just be random. It should have a precise, predictable rhythm. These are all things that the James Webb Telescope is powerful enough to look for.
And that brings us right back to where we started. Is the James Webb Telescope just showing us the birth of our cosmos, or is it showing us the latest chapter in a truly infinite story? This theory paints a picture of a universe that is so much grander, older, and frankly stranger than we ever dared to imagine. A universe that's part of an eternal cycle, one that's physically connected to other realities. And right now, JWST is giving us the tools to find out if it's all true. The data is streaming down as we speak, and the answers, well, they just might change everything.